joining us, but in a while from now.
All right, great.
Yes, sir. So it is time. With the permission of all my panelists, I hope we can start with the webinar. Saru sir, should we start?
Sure.
Thank you. Thank you. A very good evening to all distinguished panelists and participants. Bharati Vidyapeeth's Institute of Computer Applications and Management, BVI CAM, in association with Computer Science Chapter of IEEE Delhi Section, Consultants Network Affinity Group of IEEE Delhi Section, Life Member Affinity LMA Group of IEEE Delhi Section, IEEE Communication Society, and IEEE System, Man and Cybernetics, Inter-Society Relations, IRS Standing Committee of IEEE Delhi Section, Industry Relations and Site Standing Committee of IEEE Delhi Section, with the association of CSI, SAFA Society, ISTE Delhi Section, and IETE Delhi Center, welcomes you all to this webinar on 5G wireless technology and use cases. In the words of Caroline Chan, Vice President and General Manager of the 5G Infrastructure Division at Intel, 5G will bring opportunities for women in telco and IT, as well as a whole new era of communication for consumers and industries of all kinds. This quote highlights the potential of the game-changing 5G technology in the present industrial enterprise. Today's webinar is aimed at providing a high-level overview of 5G technology and use cases to the participants. The topics covered are evolution of wireless networks, need for 5G networks, characteristics of 5G network, differences between 4G and 5G networks, evolution of radio networks, introduction to key 5G concepts such as beamforming, dynamic spectrum sharing, network slicing, and multi-access edge computing. The participants will also get to understand how 5G powers use cases such as Internet of Things, IoT, enhanced mobile broadband, fixed wireless network, and private wireless network. I would first take this opportunity now to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I will first welcome Professor Subrata Mukhopadhyay, Chairperson, Consultants Network Affinity, CNA Group, and former Chairperson, IEEE Delhi Section. I welcome you to this webinar today, sir. And I would now request Professor Subrata Mukhopadhyay to commence this session with his welcome address.
Thanks, Ritika.
Thank you.
Today's webinar is on 5G wireless technology and use cases. Definitely will cover different aspects. Already Ritika has talked by none other than S. Saro Velrajan of Jinkos India Limited. As we understand in simple terms, 5G, like all G standing for the generation or the fifth generation of wireless technology, represents the changing face of connectivity. We were going through different aspects. Now, last one was 4G, so there will be a comparison. Very heartening to listen to that. Designed for maximum speed and capacity, 5G has the potential to vastly expand how data is moved and will enable a wide range of new applications and use cases that go far beyond the hitherto much popular smartphone that we almost carry everybody the length and breadth of the country or other in the world. Deep penetration is there. Benefits of 5G, as rightly said, are from the evolution of the IoT to revolutionary advances in how AI, artificial intelligence, is used in the real world. Hence, many of tomorrow's most challenging and exciting technological advances will depend on 5G connectivity, such as, but definitely not limited to, because sky is the limit. Harnessing the power of IoT on one hand, unleashing AI to the other. So far we can think of immersive gaming and virtual reality, all about these things we had one point of time or other under this platform. It's a number of lectures. So in the application front, we expect it will improve industry applications in the areas of healthcare, retail, agriculture, manufacturing, logistics, every sphere of life, just to tell some, name few of them. In short, the next chapter begins with 5G. Perhaps still we are not in a position to know exactly what will come next. With these words, I'm stopping over here. Over to Ritika to conduct the rest of the session.
Thank you, sir. I would now welcome amongst us our expert speaker for today's session, Mr. Sarvanand Vellarajan, is the Chief Strategy Officer at Ginkgo's India. Saro has 20 plus years of experience in networking technologies, working for leading companies such as Cisco, Juniper, Ericsson, and Verizon. Saro also has an MBA in Technology Management from University of Phoenix. He has held several roles in delivery management, product engineering, product marketing, and product management. Saro is also the author of the book An Introduction to 5G Wireless Networks. He is specialized in technologies such as software-defined networks, network functions virtualization, wireless networks, edge computing, and content delivery networks. I welcome you today to this session, sir, and I would now request you to kindly enlighten the House.
Thank you very much, ma'am, for that great introduction and for setting the context. I invite all of you for the session today on 5G wireless networks. Let me start my screen share. Great. Hope all of you are able to see my screen.
Yes, sir. The screen is perfectly visible.
Great. Okay. So welcome to the introduction to 5G wireless networks. 5G, like Dr. Subrato said, is a revolutionary technology. While we have seen the growth of wireless networks right from 2G to 3G to 4G, they were all producing incremental improvements in terms of speed or even performance or scale. But 5G provides dramatic improvement in terms of performance, scale, latency, and also the various use cases that are supported. In our session today, I'll be covering these topics, and Dr. Ritika has already done a great job of setting the context. So I'll get started with the session. So wireless networks came into prominence in the year 1983 when 1G was introduced. And during those days, the size of phone used to be like a brick. So it used to be so large and it was very difficult to carry. And the primary purpose of the 1G wireless technology was to support just voice calls. And since the mobile equipment was very heavy in size, and also the voice calls were handled over analog technologies, the quality of voice calls were not great. And even in terms of convenience, the mobile phones were not as easy to carry like the phones that we have today. So that resulted in the evolution of the wireless networks to 2G. 2G was introduced in the year 1992. And for those of you who used a 2G phone, Motorola Razr produced a great change in the adoption of 2G technology. 2G helped in switching from an analog-based technology to a digital technology to offer voice call services. And 2G not only supported voice calls, but it also enabled sending text messages, also called as short message services. And when 2G evolved into 2.5G, 2.5G also has the name Edge networks. 2.5G was called Edge. And Edge supported email services on top of the wireless communication link. So that was the first time ever data communication was possible over wireless network. And the speed that was offered by 2.5G network at that time was very insignificant when we look at it today, but it was just 114 kbps. So there was a growth in internet around that time, and all of you were aware of the dot-com boom. and internet gained a lot of prominence. 3G was introduced in the year 2003, around the time when the dot-com world crashed. But at the same time, pretty much all companies had a website and people were used to accessing internet services. I'm sure some of you will remember the popularity of Yahoo search engines at that time, Yahoo Messenger services, and all of them resulted in the need for supporting high-speed data. And 3G solved that specific problem. So it started supporting higher speed. So it started supporting speeds of up to 42 Mbps. And there was a big architecture change when compared to 2G and 3G, between 2G and 3G. So 3G fundamentally changed the way in which the radio network components and the core network components were designed, and that resulted in higher speeds. And all of us know that iPhone came and changed that whole ecosystem, because until then, BlackBerry was a popular device that was used for consuming data, predominantly email services. But when iPhone was introduced in the market, it combined GPS, email, camera, and many more applications into one device. So that resulted in an explosion in the adoption of smartphones, not just iPhones, but smartphones in general. So the introduction of several applications on the handheld device, the mobile phone, which was called as smartphone since the introduction of 3G, that more and more people started adopting smartphone, and there were more and more applications that were introduced. For example, one of the critical applications which whose needs were not met by 3G was video and video-based services. So we were all still remembering that the buffering link that will show up when you are accessing YouTube over a mobile phone. But that problem was solved when 4G came into existence, because 4G introduced high-speed networks. So today, 4G, for example, supports 300 Mbps. If you are wondering, okay, I'm not seeing 300 Mbps in India, the 300 Mbps is the maximum throughput that you can get, and people in US are able to enjoy 300 Mbps today. But in India, we see anywhere from 10 to 12 Mbps speed over 4G links. And we are all able to watch videos, specifically Amazon Prime and Netflix videos from our mobile phone without the buffering issue that we used to see with the 3G network. Now, why 5G? Until today, all of these previous generation wireless technologies were focused predominantly on supporting higher speeds on top of mobile devices. But there is a need that was not fulfilled by the previous generation wireless networks, which is adoption of wireless network for industrial use cases, adoption of wireless network for enterprise use cases. And that is the exact problem that 5G is trying to solve by supporting services like autonomous cars, supporting functionalities like augmented reality and virtual reality, and by enabling use cases like Internet of Things. 5G spreads the adoption of wireless technologies across newer use cases, and it is going to bring in a huge change by supporting high speeds. For example, 5G is going to support up to 1 Gbps network speed. So we are all very excited to start using a 5G phone. In fact, 5G is already introduced in several countries already. I'll be sharing with you a snapshot of the 5G adoption towards the end. But what is 5G? 5G in simple terms is the fifth generation wireless technology. And all of these generations of wireless technologies, be it 3G, 4G, 5G, all of them are standardized by a standards body called 3GPP. It stands for a third generation partnership project. While it was started for introducing 3G standards, it has held that baton to introduce 4G and 5G related standards. And 5G supports up to 1 Gbps network speed and a latency of less than 10 milliseconds. So that is very apt for services like online gaming, autonomous cars. A car moving on the road needs to make quick decisions, so it cannot wait for a response to come over the network, right? So low latency is apt for several IoT kind of use cases. So 5G supports 10 milliseconds latency over the wireless link, and that is going to result in a number of new applications and services. 3GPP standardized this in the year 2018. Since then, several countries have adopted, which includes USA, China, South Korea, and UK. So there are so many countries that have started adopting 5G. What are the key changes introduced in 5G? There are two critical changes or two major changes that are introduced in 5G. Number one, changes on the radio access network, which is shortly called as RAN. So the radio access network includes the towers that you see and the antennas that hang on the towers. And there are boxes that are normally deployed along with the towers, which is like the brain that controls the antennas. So all of these functions are called as the radio access network function. And there is a major architectural change in the RAN with 5G. That change is the radio access network function, which was traditionally run on a hardware device, got virtualized and it is run in a cloud environment near the edge of the network. While 4G also supported virtualized RAN, it was not mandatory for 4G to run services on a virtualized environment. So telecom service providers were still running those services on physical appliances. But 5G supports cloud native applications. So the RAN functionality is natively virtualized and run on the edge of the network. So that is a major change on the RAN architecture. There are a few more changes. I'll be covering them when I talk about the technologies. The second major change is the changes to the core function. The core function is something that you and I don't see in our day-to-day life. We are all used to those towers. We have seen the radio antennas and all of that, but we may not have seen the core function. But 4G is powered by a core network, which has a set of network functionalities that enable authentication of the users, that take care of policy management. For example, your bandwidth limits, your daytime bandwidth, nighttime bandwidth, the overutilization bandwidth, all of them are controlled by certain network functions. And when you roam from, for example, one city to another, one state to another, or one country to another, there are roaming scenarios. So all of these are handled and managed by the core network functions. And the major change in the core network function is these are now segmented, and they are also again supporting cloud native functionality. So they can be implemented like microservices, and they can also be run on cloud environment. The core network function also supports APIs. So you can dynamically retrieve, for example, the location of a subscriber from an application. So those are functionalities enabled by the new next generation code. So those are the two big changes. One, a change on the radio access network architecture, and number two, the change to the core network architecture. 5G core is called 5G next generation core, and 5G RAN is called the next generation RAN in 5G. Why do you need 5G? Number one, IoT is one of the major triggers for 5G, because when you talk about IoT, traditionally mobile phones, at most you may have like what, you have 6 billion users in this world. But when you look at IoT, every phone has like tens and hundreds of devices. And if you look at an industry has several thousands of devices. This includes your surveillance camera, your temperature sensor, pressure sensor, your gyrometer. There are so many devices that are available around us, and all of them need network connectivity. While you can provide Wi-Fi based connectivity at home for some of the IoT devices, think about the windmills that are running in remote location. How do you provide connectivity for those devices, right? So there is the need for connecting several millions and millions of devices to the internet, number one. And these devices are power sensitive. You cannot, for example, smart utility meters, they operate on very low power, and the network also should be power optimized. For example, some of us still remember 3G and 4G devices consume a lot of power when you are doing a lot of data transfer, right? So that problem should not be there, and that problem is solved in 5G network. So IoT is a major driver for 5G. Number two, bandwidth and latency hungry applications. Today we hear about technologies like augmented reality, virtual reality, online live gaming, online live video streaming. Especially with COVID, we are doing a lot of these sessions over internet, and all of them are bandwidth and latency hungry. So that is the second trigger for 5G. And number three, operators are spending several millions of dollars. In fact, Verizon, the company that I work for, used to spend $10 billion every year. That's a billion. So they used to spend a lot of money on black boxes from Cisco, Ericsson, and Juniper. These are custom hardware running custom software. So they want a change in the architecture where they are able to run functions on general purpose hardware. They want to virtualize networking functions. So all of those network architectural changes are happening in 5G. For example, 5G supports software-defined capability. 5G supports network virtualization. It supports seamless upgrades without any service outage for users. Right? And most importantly, it enables newer monetization opportunities. What do I mean by that? For example, in 2010, in India, we paid 1 paise for every 1 KB of mobile data. 1 paise for 1 KB of mobile data. So if we have that pricing now, we will be paying 10,000 rupees for 1 GB of data. Okay. So 10,000 rupees for 1 GB of data. Are we paying 10,000 rupees for 1 GB of data today? No. Probably we are paying 15 rupees, 20 rupees per GB of data. So that explains why Airtel, BSNL, Vodafone, all of these guys are going through a lot of financial challenges, right? So the bandwidth consumption has increased, but the cost that we pay for per KB of bandwidth or per GB of bandwidth has come down dramatically. So service providers want to enable and support new use cases and enable them, which enables them to monetize. Okay, that is why they are now focusing on Internet of Things, industrial use cases like Industry 4.0, as well as enterprise-related use cases. Let's quickly look at the differences between 4G and 5G. 4G supports 300 to 400 Mbps in lab, and in real world it can support 40 to 100 Mbps, while 5G can support up to 1 Gbps in lab, and in real world you can see 300 to 400 Mbps speed. 4G supported 50 millisecond latency. 50 millisecond is apt for online video streaming like the one that we are having now. But if you want to enable use cases like autonomous cars or high definition video gaming, you need to support 10 milliseconds or less. So 5G is apt for such use cases. So 5G supports anywhere from 1 millisecond to 10 milliseconds. There are some technologies that enable this high speed. I'll be covering them when I talk about the technology. On the frequency band, the spectrum used by 4G was predominantly in the less than 1 gigahertz range or 2 to 8 gigahertz range. But 5G supports a frequency range 30 gigahertz to 300 gigahertz. And this is called as millimeter wave. For the scientists in the group, you know, when the frequency is high, the wavelength is short, right? When the frequency is low, this data can travel or the signals can travel over long distances. So while 5G supports millimeter wave, it expects the telecom service provider to install antennas in locations closer to the users to achieve higher speeds. Okay? That's how 5G supports up to 1 Gbps by adopting the millimeter wave frequency range. Then the use cases. We use voice over LTE for voice calls. We are used to mobile broadband, online video, online gaming with 4G. But 5G is for a slightly different purpose. For example, holographic calls. Holographic calls it will give a perception that the other person is standing right in front of you. For example, a news reporter who will show up in a hologram on the studio from a remote place, for example, Afghanistan, right? So those kind of use cases can be enabled with 5G or autonomous cars or robotic surgeries. So 5G is focused on use cases that are very distinct when compared to the current use cases supported by the 4G. And 5G also supports a capability called as network slicing. I'll be covering that in a future slide. 4G supported wireless coverage with large towers, which we all have seen, right? But 5G, like I said before, because of millimeter wave support, you need to install so many antennas in locations closer to the user, and they cannot put all these large towers in large numbers in every street corner. So that is why there is a new form of radio tower or an antenna called as small cell. And these small cells are of the size of your small refrigerator, a very smaller refrigerator, I would say, probably like the size of your briefcase. and those can be hung on top of lamp poles or light poles in every street corner. So that way you can achieve the scale in terms of radio network coverage. So cell towers in 5G will be of slightly different nature. While you still have those large towers where those antennas are hung, you will also have smaller antennas which can be put underneath your office parking lot, for example, right, to provide better coverage of the network. Like I said before, 5G adopts a service-oriented approach, which means each of those functions can be run like a microservice and they can be run in different locations. And each of those services of 5G expose APIs. So even application developers can consume network information through those APIs, which is a unique aspect of 5G which was not supported in 4G. 4G used fixed connections between network elements and it did not allow application developers to tap into what is going on in the network. And the architecture followed by 4G was long-term evolution. And I said like 5G supported supports next generation core and new radio function. So 5G can be deployed in two forms today. The first form is called as non-standalone deployment. In non-standalone deployment, the radio function follows 5G standards, but the backend core network can still be 4G core. So why do we need to follow this architecture? The main reason is service providers have spent lots and lots of money in building the 4G network, and 4G network has been upgraded to support higher speeds already, especially the core network, right? Because they have fiber connectivity all around the city, specifically in cities. And what they want to leverage is the investment that has already gone into the 4G network. So the new radio function, the RAN network will be running 5G and the core network will be using the 4G infrastructure. And this is called as non-standalone deployment. The other architecture is standalone deployment. Standalone deployment has end-to-end 5G network, right from the radio access network, the tower, antenna, all of that to the core network function. While many or almost all of the deployments of 5G that are done in the world today follow non-standalone architecture. Standalone architecture, first of all, the standards are not completely vetted by the 3GPP standards body. It's not officially approved, number one. Number two, lot of commercial trials are going on with respect to standalone architecture. So if you don't support standalone architecture, there are certain capabilities that we will not be able to support. For example, network slicing is a new concept introduced in 5G, which will not be supported in a non-standalone architecture. I'll be talking about that again in a subsequent slide. But what I want to communicate using this slide is there are two forms of deployment of 5G. One is non-standalone, where you are leveraging the 4G core. The other format is standalone, where end-to-end it's 5G. Today, all deployments are following non-standalone architecture. In the future, they'll start supporting standalone functions. So let's quickly look at some of the concepts related to 5G. There are four concepts that I'm going to cover in today's session. There are many more. Okay? And the four key concepts are: number one, beamforming; number two, dynamic spectrum sharing; number three, network slicing; and number four, multi-access edge computing. The first two, beamforming and dynamic spectrum sharing, are technologies or features or capabilities introduced on the radio side. The next two, network slicing and multi-access edge computing, those are features added on the core network side. Beamforming. What is beamforming? In order to understand beamforming, I'll introduce you to a concept called as MIMO. MIMO stands for multiple input, multiple output. So it simply means that the antenna can handle multiple input signals and multiple output signals at a given time. That's MIMO. So how does MIMO help? MIMO helps in sending radio signals in different directions. Okay? So that's the purpose of MIMO. So when you dissect a large antenna, you might have seen those large antennas on top of towers, right? When you dissect those antennas, it will look like an unpeeled orange. In an unpeeled orange, there will be smaller lobes, right? Similarly, when you dissect an antenna, you will see smaller antennas inside. Okay, there will be so many radio devices, probably several thousands of small radio devices hidden inside, and each of those radio devices help in supporting the multiple input, multiple output format. So this enables you to distribute the signal across a wider range. So basically, it helps you to achieve coverage of the signal. So that has been, by the way, used in 4G LTE networks also. So it's not new. MIMO has been there for a while. But what is new in 5G is these MIMO antennas can be programmed. So what you can do with the programming is you can change the signal strength of the 5G radiations. You can increase or decrease programmatically. That is number one. And number two, you can alter the direction of the signal. Okay? That again, you can do that using program. So those are the capabilities that are introduced in 5G. One, you can increase or decrease the signal strength. And number two, you can change the direction of those MIMO antennas. So with that, you can enable functionalities like beamforming. What is beamforming? In the traditional 4G network, there is large antennas and they send signals and so-called radiations in specific patterns, and the pattern is very fixed. But in 5G, especially to support higher speeds, you need to focus the signal towards the user's device. Okay. For example, a residential user using 5G based modem, and if they want to achieve 1 Gbps network speed, then the antenna on the radio tower has to be programmed to concentrate the signal towards that particular home, so that the residential 5G modem gets increased signal rate as well as it is able to achieve higher speeds. Okay, so that technique is called beamforming, where you are able to send signals focused on a particular device towards a particular direction, and you can control the signal strength programmatically, and it helps you to reduce the number of interferences, right? When you're sending signals, for example, if there is a tree, and today's antenna will not change its direction irrespective of whether there is a tree or whether there is some obstruction in between. It sends, today's 4G antenna sends signals in all directions. That's all, it's static. If there is an obstruction in between, that radio antenna's direction will not be changed. But in 5G, you can programmatically change the direction of that radio antenna so that you can concentrate the signal towards a particular direction or a particular user. And that's beamforming. And beamforming helps you to achieve higher speeds in 5G. So that is one technique. The next technique is on the radio side is dynamic spectrum sharing. This is a very interesting use case, and this predominantly helps the service provider more than the end user. Okay, the service provider goes through a lot of pain when they are migrating from one technology to another. For example, when they migrated from 3G to 4G, they still had the 3G network running for a while before they completely obsoleted the 3G network. So which means they have to keep the 3G network running as well as the 4G network running simultaneously, which means more operational costs, more labor to maintain those equipment. So which means they will not be able to spend that money or that capital on newer technology and newer innovation. Okay, and on top of it, the 3G users will get half of that coverage and 4G users will get half of that coverage. Both will keep complaining, saying, "Oh, I'm not having enough signal," or "I'm not having better coverage." Right? So let's see how the world was without this new concept called dynamic spectrum sharing. Okay. The phone has to, if you look at the specification of your 4G phone, it will have even the frequency ranges supporting 3G, and some phones will even support 2.5G today. And for each wireless technology, you need to have a separate modem embedded in the mobile phone, which means your cost of your mobile phone will go up. Some of you might have noticed when you are in the city, your phone will say 4G. When you move outside of the city, probably to a village, the phone will say 3G or 2.5G. Okay, edge. You may see the symbol edge, right? So what it means is your device has a 3G antenna, edge antenna, as well as the 4G antenna. So you are paying a higher premium for the device to have those different technologies, right? So the cost of the phone also goes up without a dynamic spectrum sharing, where you have dedicated towers for 5G, dedicated tower or dedicated antennas for 4G. Now let's see what happens with 5G and dynamic spectrum sharing. So what happens with dynamic spectrum sharing is you have to do a software upgrade on the 4G antenna. When you do a software upgrade on the 4G antenna, the 4G antenna will support both 5G's users as well as 4G's users. And for example, if you still remember the content that we went through in the 4G versus 5G slide, there were certain frequency ranges that are common for 4G as well as 5G, right? For example, the less than 1 gigahertz spectrum was common for both 4G as well as 5G. So what you can achieve here is you can provide 4G speeds to 5G users, especially from that tower, especially from your 4G LTE tower, without the need for the mobile phone to have two modems. As far as the 5G phone is concerned, it doesn't know that it is getting signal from a 4G tower. It will still show the signal as 5G, but probably you will see lesser speed. But your cost of your device would have come down because you are not having that 4G modem in your 5G phone. That is number one. That's a benefit for the user. For the service provider, they are able to roll out 5G faster. For example, if Reliance or Apple has to roll out 5G today, they can do a software upgrade of their 4G network and enable 5G services immediately. Of course, the 4G speeds have to be improved in India. Today, for example, in USA, the 4G network offers 300 Mbps speed already, while the 4G in India offers anywhere from 10 to 12 Mbps speed, right? So they have to upgrade the capacity of the 4G network and then start rolling out 5G services. So the advantage for the service provider is they can slowly obsolete and outdate the 4G equipment. It enables them to roll out 5G services faster to covering a lot of users. That's the advantage of dynamic spectrum sharing for the mobile service providers. Now let's look at a concept called the network slicing. I've been repeatedly saying network slicing. So in the traditional 4G world, the network, specifically the radio function, doesn't differentiate user A versus user B. All users have equal time slots, and the spectrum and the capacity, radio resources, all of them are equally shared by several users. Imagine a stadium, a football stadium or a cricket stadium where there are like 10,000 users sharing the same radio resources. I'm sure you might have noticed that in some locations where there is a lot of crowd, you will find it difficult to even get a signal. Even if you get the signal, your voice call may not go through. That's because 4G treats everybody the same. That problem can be solved with network slicing. So what happens in 5G is you are carving out slices of network. Basically, you are segmenting the network right from the radio all the way to the core network and offering different quality of service parameters and the performance and capabilities at each of those network slices. If you are a premium user who always want signal and the ability to make voice calls irrespective of the number of users in a particular location, then you sign up for a higher package, which guarantees a higher quality of service right from the radio all the way to the core, right? So if you want to make a voice call, then you can make a voice call without interruption, irrespective of whether there is only 10 users in a room or whether there are 10,000 users in a stadium. Okay, so that's a simple example. But you can also, service providers also get benefited by this network slicing capability, where they can carve out a network slice for use cases such as autonomous cars, because autonomous cars need uninterrupted service, and they cannot, for example, a car cannot stop near the signal trying to figure out whether the person crossing the road is like it's a human or it's an animal or it's like just a moving truck. So all those decisions have to be made in real time. So autonomous car would need a network slice where the latency is ultra low. Okay? But your voice calls can be run in a network slice where the latency can be like 50 milliseconds. It's still okay. Okay? So that's the benefit of network slice. It improves the user experience. It enables service providers to monetize the network more. Then comes multi-access edge compute. I said 5G is able to support higher speeds by relying on certain technologies, right? Multi-access edge compute is one such technology where there is an edge compute infrastructure that is right near to the user, and your Netflix and Amazon Prime videos can be streamed from the multi-access edge compute so that you don't see any big difference in big impact on the performance. You would see higher latency. Or if it's an online gaming application, these applications can be hosted in edge locations closer to the user. If you are running an application in a data center, probably you will notice 50 milliseconds to even couple of seconds latency. But if you are running the same application in an edge location closer to the user, you can notice 20 milliseconds to 10 milliseconds latency. And there are times when if the application is optimized, you will even see less than 10 millisecond latency. And that is the purpose of edge compute. Specifically, it helps in industrial use cases where, for example, there's a remote industry, power or utility industry, where they have so many machineries connected to the network, and these robotic arms that are assembling the cars or controlling the power grid, they need ultra fast responses from the network, right? And that can be achieved by hosting applications on the multi-access edge compute. The difference between multi-access edge compute and traditional, the so-called CDN, right? You might have heard of caching appliances deployed in service provider networks. Those were there even in 4G. The difference between those and multi-access edge compute is in 4G, you have custom specific applications or hardware for each application. For example, Facebook will put a hardware in the service provider location for delivering Facebook applications. Google will put a server in Reliance location for delivering Google's services. But multi-access edge compute allows anybody to write an app and put in a virtual environment. So it provides a shared infrastructure for app developers to host their services. Let's quickly look at the use cases of 5G. The first use case is Industry 4.0. Some of you might have heard this term Industry 4.0 here and there. The key aspects of Industry 4.0 is number one, connectivity, because traditional industries did not connect all of their equipment to the internet. That is connectivity, number one. Number two, monitoring. So the traditional way of monitoring was by sending a person and physically inspecting everything in person. But here with Industry 4.0, the monitoring is automated. You can collect all kinds of data and insights by remotely monitoring these devices over the internet. That is number two. And number three, automation. When you are able to monitor, for example, the health of a device, you can also do some automation to fix problems. For example, you can do a predictive maintenance of your equipment by continuously monitoring them. And if an equipment requires a software upgrade for it to function effectively, you can do a remote software upgrade. So some of those capabilities are enabled in Industry 4.0. So when you talk about devices that are connected over to the internet in an industry, it can be surveillance cameras, it can be the pipeline that is manufacturing products or goods. For example, in a car manufacturing plant, there are robotic arms that assemble the cars, and those can be connected to the internet. Or in a warehouse, there are robots that are moving from one aisle to another aisle, taking goods from the rack and putting it on the supply chain, the delivery pipeline. So all of those are connected to the internet today. So, and heavy machinery can also be connected to the internet. So there are different types of devices which can be connected to the internet in an industrial scenario. And traditionally, they were using protocols like Zigbee or long-range wireless. There are different, or even, for example, you can use 4G technology or 3G technology for connecting these devices to the internet, but those were not effective. Specifically, they were not supporting lower latencies, or they were not providing wider coverage, or they were not power optimized. Those wireless technologies were not power optimized. And that's where 5G helps. So today, an Industry 4.0 company can put a private 5G antenna on the prem, which is connected to the service provider's 5G core or 4G core in the backend. So the advantage of having private 5G locally is higher coverage, and ability to connect more devices locally. And the enterprise or the industry will also have total control over what is transferred over the network. Because some vendors will be worried about the security of the network connections, right? So private 5G guarantees the security of what is transferred over the internet. Specifically, if there is application that deals with confidential or secure data, those applications can be locally hosted on your IoT gateway and run locally. Whatever is non-sensitive, that alone can be transferred to the IoT applications running on the cloud. So this architecture is supported in 5G, where you can have a private 5G radio antenna on your prem, which is connected to the service provider core. In fact, 5G also supports end-to-end 5G network, even the core sitting within your prem. Okay? That is possible. Then other use case in healthcare. This sounds fancy, but parts of it can be done already with 5G network today. So one of the use cases that is targeted with 5G is robotic surgery, where you might, I'm not sure how many of you are aware, India is turning out to be the destination for healthcare, low-cost healthcare. People from abroad, US, UK, even Middle East are traveling to India to avail healthcare services because treatment, for example, cancer treatment or diabetes treatment, all of them are very low cost in India, or even a simple eye surgery is low cost in India when compared to other countries like US and UK. So there are so many people who are traveling to India to get these services. Now, some of those services, specifically the consultations, can be done remotely. If it is a minor surgery or minor procedure which has to be done, that can be done by surgeons who are remote, and it can be done over the wireless network. Specifically, 5G supports ultra low latency. And go and search in YouTube for remote robotic surgery. You will see those videos where a doctor is able to control the robotic arms on the other side, which does, for now, it's a simple procedure. They can do simple procedure like stitching a wound, right? That can be done. And it also helps in times of pandemic like this, right? We are even afraid of going to hospitals today because we are afraid that we'll acquire COVID from the hospital. So some of those problems can be solved when there is remote consultation and use cases like robotic surgery. Then enhance mobile broadband, and we are starting to see some of these in India also. When you go to railway stations, when you go to coffee shops, now you see Wi-Fi connectivity, which is offered everywhere. And one of the challenges of providing Wi-Fi connectivity here is, for example, you have to run cables to connect all the devices to the internet. But with a 5G based customer premise equipment, you can just put an equipment and it doesn't need a backhaul connectivity to your fiber network. It can wirelessly connect to the WAN, wide area network, while it locally provides Wi-Fi based connectivity. And it is apt for use cases like rail transport. So for example, many countries, they are offering Wi-Fi services on trains, but they are not of high speed. Today with 5G, you can put a 5G customer premise equipment on the trains, in each, probably one each in all compartment, and they will get connected to the internet via 5G, but the users will get uninterrupted Wi-Fi connectivity. You might have gone in trains where they have video consoles, right? You may ask me, okay, why not user directly connect to 5G? Why they have to use Wi-Fi, right? But there may be consoles or lights or temperature which has to be controlled remotely, and those devices at least can connect over Wi-Fi to the internet. So some of those services can also be enabled. Then Wi-Fi hotspots, we have all used it. 5G CPE helps small businesses to get instant wireless connectivity. Because today, if you want to get fiber connectivity, it may take at least 2 to 3 days. Or if you want a secure connectivity to the wide area network, it may take a longer time. It may take even 30 days if you want to connect all the hundreds of coffee shops to the internet, if you are a Starbucks. But with 5G, you can put a 5G CPE in each of those 100 coffee shops, and you can connect them securely to the internet in a day. Okay? There is no lead time, and you can also connect all those offices together using SD-WAN, which runs on top of internet. So you can achieve seamless connectivity of hundreds of your small branch offices without a long lead time, as well as you can provide Wi-Fi connectivity to your customers. That's enhanced mobile broadband. Then the last is fixed wireless deployment. While if you walk out in the roads in cities, you may see hanging cables all over the city, and it's a menace to a lot of people and specifically to the corporation, right? You see cables hanging and going all over, and that problem can be solved with the fixed wireless deployment, which means you just get a 5G modem and put it in your home, and you get connectivity option for your television, voice, mobile, laptop, whatnot, right? 1 Gbps is more than enough for the entire street, I would say, considering India's use cases. But this is real. The fixed wireless deployment is happening in US and elsewhere, and speeds up to 900 Gbps are noticed in fixed wireless deployment. Okay? So it eliminates the need for sending a technician, run a cable, and drill a hole in your wall to provide connectivity, broadband connectivity to the applications in the home. Instead, you can just buy a modem and put it, and you will get instant connectivity. Okay? So that's the advantage of fixed wireless deployment using 5G. So what is the status of 5G? There are close to 100 operators across 61 countries offering commercial 5G networks. And this includes operators like AT&T, Verizon in US, or EE and Etisalat in Europe and Middle East. China, several China telecom vendors like China Telecom and China Unicom are offering 5G services. South Korea Telecom in Asia Pacific is also a pioneer in offering 5G services. So there are so many countries that have already deployed 5G. Now the next question is, okay, what is happening in India? Why are we not getting 5G? So there are trials, 5G trials happening in India since 2018. And Reliance and Airtel have already demonstrated 5G capabilities. They have tested 5G capabilities in different locations. But because of initially the plan was to do spectrum auction for 5G in late 2020, then it moved to early 2021. Then because of COVID, now the spectrum auction is pushed to 2022. So it is expected to happen in the first part of 2022. And as we might have heard from Reliance and Airtel, Reliance is almost ready because they acquired a company called Radisys, which manufactures 5G equipment. So they can put homegrown 5G equipment to power up 5G services in India. Airtel and obviously Reliance is also doing trials with Ericsson and Samsung. So they'll still buy equipment from others. Airtel also has done trials with Nokia, Ericsson, and Samsung. So in terms of readiness, they have tested the technology, they have conducted trials. The spectrum auction is pending, and that's why 5G services are not launched in India. And as per research reports, there's going to be close to 33 crore 5G users in the next 4 years, 5 years, by 2026. Today, we have 72 crore users on 4G network, and that count will go to 83 crores by 2026. But we'll have close to 33 crore users or devices accessing 5G by 2026. So I'm sure all of you in this meeting will also get a 5G subscription as and when it is ready, right? So that brings us to the end of the session. Probably before summarizing, I can even take some questions and I can summarize at the end. I'll pause here for questions.
Thank you, sir. It was a wonderful session. The best thing is that wonderfully you have explained the different workings and implementation of 5G. We have a number of questions. I will be taking out few of them which have a lot of things in common. The first question that we have is, what are the key challenges to be considered while implementing the network slicing on RAN and CN, specifically on security in network slicing and mobility management in the same?
Great, ma'am. So, in fact, the question itself has some aspects of the answer, which is the number one criteria or the concern that people have today when somebody talks about network slicing is security. Because we are all not used to sharing the radio frequency and specifically the spectrum and radio resources across multiple applications. And when you talk about enterprise, right from the beginning, I've been emphasizing that 5G is for corporates, 5G is for enterprises. 5G is not for ordinary users who are watching probably Amazon Prime or Netflix, because we are comfortable with 4G itself, right? But 5G is for enterprises, IoT deployments, and industrial use cases, and they are more concerned about security. So 5G offers a number of capabilities to provide that security. For example, we talked about network virtualization, where you can have dedicated virtual instances of network functions that are marked for certain services. For example, if I am an Industry 4.0 user and I want my own dedicated virtualized RAN offering a specific network slice for my own application, you can achieve that in 5G. And you also, so all of those 5G connections are fundamentally encrypted. In fact, 5G supports higher, for example, it supports up to 256K encryption, which is higher than the standard 128K encryption supported by the 4G. So natively it offers encryption. You cannot tap into each other's data traffic. But 5G also offers firewall and policy management capabilities right from RAN. So one beauty of 5G network is end-to-end, it's IP enabled. So IP also offers encryption, as well as you can deploy protocols. For example, if you are concerned about 5G security, you can run your own application protocol like IPsec to achieve security, or you can even have your own way of encrypting your data and create a tunnel like WhatsApp. Today, nobody can read what is sent over a WhatsApp communication. So if enterprises are challenged, since 5G is IP enabled end-to-end, the enterprises can have their own security protocols, or they can leverage some of the capabilities offered by 5G itself, in terms of firewall policies or network policies, which are configurable and manageable. So security is not should not be worried about too much when you talk about network slicing. That is number one. Number two, bandwidth, because the resources are getting shared across multiple people. The way in which the overall bandwidth gets shared across multiple people, and what happens is the winner takes all problem, right? So when the one who takes more will get all the bandwidth, and there's a chance for the regular users like you and me to get stuck, and that has to be taken care of by the service provider. So service provider has to fine tune the configuration to ensure that there is some amount of bandwidth available for all the other users before carving out bandwidth for their premium customers. And service providers are good at that. For example, today I know service providers like Verizon always have a reserve capacity of 40% or even more in many of their networks. So there is enough capacity that is kept in the reserve to ensure that the spikes are handled in the network side. So those are the two main concerns that normally happen. One is security and the other one is bandwidth management. And 5G offers mechanisms to handle them.
Thank you, sir. Another question we have is, how are we going to deal with about to obsolete G like 1G, 2G, etc. and these devices and their setup? And I would add to this question that, okay, urban India, 5G, 4G, it is very common. But if we talk to rural India, today, even 2G over there, it's very common. Like they are still struggling with 2G. And talking about in the present times, like how are we going to deal with this wide gap between urban and rural India? And yes, what are we going to do with these like 1G, 2G, which sooner or later will have to become obsolete with the pace that the world today is digitizing? Okay. So what about this?
That's a valid concern, ma'am. In fact, even in developed countries, right, let alone a country like India, but even in developed country, the coverage of these high-speed networks in rural location or remote villages is very less. Probably they may be getting only 3G speeds today, though Verizon and AT&T probably says that they offer nationwide 4G network or nationwide 5G network, while the definition of nation includes only those prime cities where there are concentrated users. So what they are trying to do is, obviously 1G network is not anymore there at all. but there are traces of 2G and traces of 3G networks that are there in the world. And in fact, those networks have now found application in IoT type of use cases, because IoT devices do not normally require higher bandwidth. So they'll be sending data in small numbers over a period of time. For example, a utility meter that is sending readings of your electricity consumption, right? It doesn't require 1 Gbps network speed. So some of those can be run on 2G and 3G network infrastructure. So that is happening in some parts of the world. And countries like US are also shutting down 3G networks and 2G networks. In fact, vendors like AT&T and Verizon have given a plan to shut down their 3G network by 2022. So what they'll do is, when they shut down that network, they'll repurpose the frequency range and capacity for the 5G users. Okay? 5G also supports some variations called as they support unlicensed spectrum ranges. Okay, so what does that mean? You can put your own 5G network in any location that you want without having to get any approval from the government also. Okay, so you can run your own 5G network. So that will enable telecom service providers to extend the reach. For example, they don't have to spend a lot of money on the spectrum. Instead, they can provide internet connectivity services, mobile internet connectivity services, by deploying unlicensed spectrum equipment that runs on unlicensed spectrum. So 5G, the beauty of 5G is you can have your own private 5G network, and they can put a box called as private 5G in every village and provide 5G services or 5G connectivity services using unlicensed spectrum, so that the telecom service provider don't incur huge costs. They'll still need to run fiber till the last mile to connect to the private 5G equipment, but they don't have to necessarily install so many towers and provide so many costly equipment near those users. Okay? So that is the advantage that they get, and 5G at least increases the hope of connecting these rural places when compared to 4G and 3G.
Thank you, sir. One more question I would be taking up. How is 5G more secure to cyber attacks, and what are the inherent, I would say, health hazards and natural hazards, especially to like our other living beings like birds, etc.? Like, how is 5G going to be hazardous to them also?
Good. So I'll talk about the cyber attacks. In fact, the concern about cyber attacks is not very specific to 5G. It is there even today in your broadband, fiber, 4G, all of that, right? And we already have technologies like deep packet inspection, intrusion prevention systems available, and these systems, the special purpose firewalls, can handle denial of service attacks, even distributed denial of service attacks. There are so many capabilities that are already available in the network infrastructure, which can be leveraged for offering cyber attack protection in 5G as well. But talking about radiation, so I'll share my view on what is proven and what is not proven. Okay, so what is proven is extended hours of exposure to radiation cause harm to any living creature. Okay, so which means if you put, for example, if you have a microwave oven and you put a rat inside the microwave oven and giving radiations continuously for a day, probably, I mean, I'm not talking about heat, but exposing it to radiation, right? So exposing a rat, putting a rat in a device like a microwave oven and exposing it to radiation continuously for a week, probably the rat will become something else, or it will not be existent at all, right? If you are exposing it for a week. But so that is proven, by the way, which means extended hours of exposure to any form of radiation is harmful to human beings. What is not proven is the way in which we are consuming wireless services today, like be it 4G or 3G, as far as you are not like living under the mobile tower 24/7, especially sleeping under the mobile tower, right? So even that, for example, we have not seen. There are mobile towers installed on apartment complexes and residential buildings, and those people are still good. Okay, I've seen cases where people say, "Oh, I got cancer because my house had a mobile tower." Right? The people who did not live in a house with a mobile tower also got cancer. So the cause for the cancer need not be the reason why somebody is living under the mobile tower, right? But in general, staying away from radiations is good. Research has not proven that 5G results in increase in radiations. Though they are putting towers in locations closer to the user, it's not like we are living under those mobile towers or we are spending time hours 24 by 7 under the mobile tower. Even the mobile radiation, right? They say, yeah, don't give it to kids because probably when kids are exposed to this for a long time, it may cause some impact. So any radiation is bad. So we have to balance it out between evolution and existence, right? There is always a competition between evolution and existence, not only with respect to 5G. Pick any technology, pick any development in any field. There is always a competition between evolution and existence, the evolution of a technology and existence. So you have to balance it out. So far, research has not proven that 5G is worse than 4G or even 4G is worse in terms of affecting the lives of birds. We have all seen some movies and we imagine that we don't have birds in the city because of the 4G tower or the 3G tower. But those birds are actually missing because we don't have as many food sources. We don't have as many water sources in the city. And that is why those birds are not in the city, but not just because of 4G or 3G towers.
Thank you, sir. One last question before we would proceed further. In terms of power consumption, as we have already discussed in the session, yes, 5G has higher power consumption as compared to 4G. But what are the ultimate, I would say, cost benefit ratio of this higher power consumption? Our participants will also like to know that.
I'll correct that question because probably I don't know if I communicated it right. 5G optimizes the power consumption, which means the amount of power consumed by the radio signals in a 5G network is 10 times lower than when compared to the power consumed by the 4G. So that is the exact reason why you are able to use 5G for IoT type of use cases, because a smart meter deployed in a remote location will have a battery and the battery will have a specific lifetime. So the power consumption of 5G is already optimized. It is 10 times better than or 10 times lower when compared to the consumption of power in a 4G network. Remember, we used to have this problem with 3G where when you turn on data, your battery will drain like very fast. But we don't have that problem in 4G already. But 5G is even more optimized in terms of power consumption.
Thank you, sir. I suppose I have covered all the queries of our participants. So I'll request you to kindly continue further with the session.
Okay. Thank you, ma'am. And I'll wrap up the session. And oops,
yes.
I don't seem to have the screen share access.
Okay. Uttam, sir, can we...
That's fine. So I want to summarize by re-emphasizing some of the key points that we covered today, right? Number one, 5G technology is the 5th generation technology which supports up to 1 Gbps network speed and latency of less than 10 milliseconds. So that is number one. And number two, 5G introduces several key technology changes, specifically on the radio access network as well as on the 5G core. So the new radio is called next generation RAN. The new core network functionality is called next generation core. Those are two significant changes introduced in the 5G network. And number three, 5G is able to support higher speed, lower latency because of several technologies such as beamforming and technologies such as dynamic spectrum sharing, technologies such as multi-access edge computing and network slicing. And 5G enables use cases such as robotic surgery, industrial 4.0 use cases, enhanced mobile broadband, and fixed wireless deployments. So 5G in India is expected to start, especially commercial services, is expected to start by 2022 because the spectrum auction have not started. So those are the key points that I want to emphasize at the end. Thank you so much for the opportunity. You can get in touch with me if you have further questions. My email ID is svelrajan@gmail.com. I'll type it in the chat window so that everybody can note down. And thank you so much. Back to you. Dr. Ritika ma'am.
Thank you so much, sir. It was a wonderful session. I hope it has cleared the doubts of all our participants. Actually, many of my doubts about the technology have also been cleared with the session. So thank you so much for the wonderful session. Huda sir was about to join, but due to network issues at the place where he is currently, he is unable to join. So, but I convey his best wishes to you. Thank you so much for this session. I request you to kindly accept the certificate from our side as a token of remembrance for this wonderful session today.
Thank you so much, ma'am.
I think there is an issue at my end also. I am unable to share the certificate, though I am using 5G. Yeah, now it is shared. So, sir, please accept this certificate as a token of appreciation from our side and a remembrance for this wonderful session today. So, thank you so much once again for this wonderful session. It was really wonderful having you here and clearing a lot of doubts that was surrounding this 5G technology in all of our minds. So, thank you so much, sir. It has been a wonderful session, and I suppose we have almost covered. Like I would say, this is the first session we have had, in many of the sessions we have conducted, where we have taken almost all. We have tried to cover almost all the doubts of the participants that we have had. So thank you so much, sir. Thank you once again for this wonderful session, and it has been a wonderful session. So with this, I would thank all my distinguished panelists. I'll first of all, once again, thank Saro sir, who has taken out time from his busy schedule and made this session possible today. So thank you so much, sir, once again. Thank you, Ajay sir, for helping us arrange this session wonderfully. And I also thank all our distinguished panelists and participants who have continuously supported us through this webinar. A big thank you to all of you who have joined us today on this auspicious day. I'll thank all my participants who have been with us through this session. I hope you have made you have gained maximum knowledge out of this wonderful session. Thank you, Subrata sir, for being there continuously throughout all our webinar series and I would say motivating us through each and every session of ours. So thanks a lot, sir. With this, we now come to the end of this session. We will be back on 11th September with another session of ours. So we have already shared the feedback form for this session in the chat window. I request all my participants to kindly click on the feedback form and fill in their details carefully. Once you submit the feedback form within a matter of 5-10 minutes, you shall be receiving your certificate of participation from this for this session. So right. Thank you, dear participants.
Yeah.
Yes, sir.
Dr. Ritika, I would like to once again thank you, Saro. Saro, wonderful session, a very good 5G session. And Dr. Ritika, the way you conduct very timely question answers, the energy that you bring in, and Professor Subrata, it's always pleasure to see you.
Thank you.
I always see you. You are attending all sessions. You are spending full time, which is.
I'm getting a chance to learn also on different disciplines. That's the advantage.
No. You are a learned professor, and I've seen a lot. But yeah, pleasure to see you always. So Saro, thank you very much. Excellent. We'll look forward to more session in different technologies. And Saro, if you want, you can drop off, and rest of the activities will continue. But thank you once again. Bye-bye.
Thank you so much, Jay. Thank you so much for that support. And Dr. Ritika ma'am, Dr. Subrata sir, thank you so much. Bye-bye.
All right. Bye-bye. Take care.